There are two presentations in our session. Let me invite the first presenter, Mr. Marcus Tang, to present the Envisioning a Secure, Hyper-Connected Future, Cybersecurity for 5G, 6G, and beyond.
Hello, afternoon. My name is Marcus Tan. So I head up the cybersecurity department in the I2R. So in that department, I work with a team of 30 plus researchers working on the various R&D challenges in the cybersecurity domain. So the title of my talk today, Envisioning a Secure, Hyper-Connected Future, Cybersecurity for 5G, 6G, and beyond. So we are moving into a world that is increasingly hyper-connected, from smart cities to autonomous systems, from drones to IoT devices, all powered by the next generation wireless networks. But connectivity alone is not enough. We must ensure that these networks are also secure and trustworthy. That's why today I'll be speaking about cybersecurity for 5G, 6G, and beyond, and how we can safeguard the communication backbone of our digital society. This will set the stage for the rest of the talk, where I'll share some of the opportunities, risks, and ongoing initiatives we are working on at A*STAR to prepare for this future. As we step into the next generation of connectivity, 5G and 6G will power our future economies. These networks are not just about faster speed. They are the digital backbone for autonomous cars, drones, smart factories, and smart cities. Entire industries and societies will depend on them. All of these run on the same connected infrastructure, and with that level of dependency, a single serious cyber incident could have consequences that will impact at the national or even global scale. So if we fail to secure these networks, we don't just risk the infrastructure, but we also are talking about the national security. So securing a hyper-connected 5G and 6G networks is no longer optional. It is the foundation for trust, resilience, and future innovation. So let's talk about, when we move to 4G, from 4G to 5G, what are the challenges? So as we transition from 4G to 5G, the architecture of networks has fundamentally shifted. And with this shift comes both great opportunities and new security challenges. In 4G, networks are largely hardware-centric, relying on proprietary equipment, hardware. The attack surface was narrower, more controlled. But in 5G, everything is becoming software-centric, with cloud-native functions, virtualized network functions, APIs, and AI-driven services. This brings agility and flexibility, but it also introduces many new vulnerabilities. Every software layer becomes a potential target for attackers. This means defending 5G isn't just about the hardware anymore. The 5G core itself has become a critical battleground. So unlike 4G, which was mostly hardware-centric, 5G is highly virtualized, cloud-native, and software-driven. That shift expands the attack surface dramatically. Let's look at some of these attack surface. Cloud-native function, or CNF. These are software functions designed to run in containers orchestrated by Kubernetes. They bring agility and scalability, but also new risk. A single misconfiguration or weak container policy can compromise critical network behavior. Virtualized network functions, or VNF, these run on hypervisors and orchestration platforms. Multi-tenancy means a single weak spot could be abused to spread across multiple network slices. API and service exposure. 5G relies heavily on APIs for its service-based architecture. But every exposed API is a potential entry point for attackers if not secured properly. Management and orchestration acts as the brain for the network, coordinating slices and services. On top of that, AI is increasingly used as an optional helper in 5G, optimizing resources, detecting anomalies, and managing traffic. But there's a risk. If MANO is compromised or if attackers poison AI inputs or manipulate its decisions, the effect can cascade across the system, misdirecting traffic, suppressing alerts, or even enabling large-scale service disruption. Furthermore, the 5G core connects both to the RAN on one side and the internet on the other side. That means threats can come from both directions. Security must defend the core against attacks from all sides and inside simultaneously. So in short, defending 5G isn't about protecting just one door. It's about securing every layer, every interface, and every direction of attack. The 5G core must be fortified simultaneously against threat coming from the RAN, the internet, and even within its own virtualized function. And this complexity creates unique challenges for 5G security. We have latency-critical requirements like URLLC, billions of devices through massive IoT, exposed API and services, risk from slice misconfiguration, and even AI decision manipulation. Now here's something to note. For enterprise, 5G security is a commercial driver. If their private 5G network is compromised, their entire business operations, factories, logistics, services could be disrupted. That's why they will pay for a cybersecurity solution. For governments, 5G security is a national security necessity. Even if cybersecurity for public 5G networks is not as commercially lucrative as private 5G, public 5G networks carry critical infrastructure and essential services. Any compromise there could have nationwide consequences. So while both perspectives are connected, the motivations is different. Enterprise invest to protect business interests, while government act to protect national cyber resilience. I believe the commercial potential of a cybersecurity solution is far greater in private 5G networks than in public 5G deployments. End users generally assume that cybersecurity in public 5G is the telco's responsibility. They expect security to be built in, and they generally are not willing to pay extra for it. But the situation is very different in private 5G networks. Here, enterprises deploy their own private 5G cores, tightly integrated into their operations, whether in factories, logistics, or critical infrastructure. In this case, the private 5G network becomes part of their enterprise network itself. Any vulnerability in private 5G, in this case, can compromise the entire cybersecurity posture of the enterprise. And this is where the commercial opportunities open up. Enterprises are, in effect, in a way, becoming their own telco. But while they see the values in running private 5G, many do not have the telco grade technically and operationally to manage the cybersecurity challenges that come with it. So this creates a strong market opportunity for 5G cybersecurity service providers who can step in to fill that gap. This is why the real commercial opportunity for 5G cybersecurity lies in private 5G. Enterprises have both the need and the willingness to invest to protect their operation. But at the same time, I want to stress that while money is in the cybersecurity solutions for private 5G networks, cybersecurity in public 5G is still important. These are national infrastructure. Any compromise at scale is not just about business problem, but a national security issue. So in short, the commercial potential is in cybersecurity for private 5G, but the strategic imperative is to secure both private and public 5G networks. So as enterprises adopt private 5G, the next frontier they must secure is the 5G edge, which offers immense value, but also opens up brand new attack services. So the 5G edge is a new frontier of connectivity. By pushing compute power closer to devices, we unlock ultra-low latency, better local control of sensitive data, and reduce backhaul traffic. This is what enables mission-critical applications like remote surgery, factory automation, AR, VR, and autonomous transport. But the edge also comes with its own risk. Edge nodes are often physically exposed, making them vulnerable to tampering. These attack surfaces become highly distributed with many more points to secure. And the supply chain risk is real. Compromised hardware or backdoors in edge devices firmware could undermine entire network. And to make the edge truly viable, we need to rethink how security is built in. Zero trust models, every access request must be verified continuously and contextually. Hardware roots of trust embedded directly in devices to verify firmware integrity and ensure that equipment has not been tampered with. Continuous monitoring, because the edge is dynamic and distributed, and we need real-time visibility across thousands of nodes to detect and contain attacks early. Without these safeguards, the edge risks becoming the weakest link and open doors for attackers to bypass secure 5G calls and compromise enterprise or even national infrastructure. So as the 5G expands towards the edge, the attack surface grew even wider. And this sets the stage for an even bigger gap, a bigger leap where we move from 5G to 6G, where intelligence, sensing, and AI will be built directly into the network fabric. Now let's look at what's the difference when you move from 5G to 6G, whereby AI shift from being optional in 5G to becoming central in 6G. So in 5G, networks become largely software-centric, which give us flexibility, but also expanded the network attack surface significantly. AI was introduced, but only as an optional helper, something that could optimize or assist in certain processes, but not essential to the whole network itself. But in 6G, there's a profound shift. Instead of AI being an add-on, it becomes AI native by design. AI will be built directly into how the network operates, including real-time autonomous resource management at every layer, from the air interface to the way data flows across the network. AI at the edge. In 6G, native hosting and training of AI models can happen directly at the network edge to allow decisions to happen in real time, close to where the data is generated, reducing latency and opening up new applications that weren't possible before. So in summary, while 5G expanded capabilities but also vulnerabilities, 6G transforms AI into the central nervous system of the network. This shift opens up huge opportunities, but also raises new challenges for trust, security, privacy, and resilience. So these are the potential 6G AI vulnerabilities. AI model poisoning. Here, attackers inject malicious samples into the training pipeline, corrupting models so that they make wrong decisions in the telecom. So in the telecom network, that could mean misallocating spectrum or failing to detect threats. And we have other things like model extraction and IP theft. Attackers can reverse engineer AI models to steal proprietary control logic or replicate intellectual property. And finally, AI decision manipulation. By subtly manipulating input telemetry, attackers can nudge AI threshold in their favor, misrouting traffic, degrading services, or bypassing protection. So these are just the first wave of AI vulnerabilities we should worry about. But as we go deeper into 6G, there are more systemic risks that will appear. For example, bias and discrimination, over-reliance on AI autonomy, AI supply chain risks, and privacy leakage from edge AI. So when we talk about AI in 6G, we need to prepare for not just adversarial attacks, but also structural risks that come from how AI is deployed at scale. Now, beyond AI-specific risks, there are other critical privacy and security challenges in 6G and 5G. For example, talk about user privacy related to ISAC, and also roaming security. So attackers will always target the weakest link, and right now, legacy networks interoperability is that weakest link. So how do we defend against all this? Basically being AI-aided defense, and also defending the AI model used in 6G, as well as zero trust. These are the two possible approaches. Okay, next, due to the time constraint, I will straight away jump to this telecom cybersecurity innovation. So in view of all these challenges and risks, how do we intend, what are we doing at I2R, A-Star, to prepare for this future? So we do it through this Telecom Cybersecurity Innovation Center. So the tagline of this is to build resilience and trust in Singapore's telecom infrastructure. And this is a project funded by CSA through the CRPO, and it will end middle of next year for phase 1. And the objective is to develop two platforms. One is the 5G attack platform for private 5G, and the other one is to 5G security integrated platform on how to do this detection of such attacks. So here, the special thing about this project is we're looking at from R&D to commercialization. So the vision and mission for TSEC is to, right now we will work at looking at attacks and defense in private 5G. We will adapt it to public 5G later, and then going forward, beyond that is to evolve that to support 6G when it's ready by 2030. So our vision is to be a leading R&T and innovation hub in cybersecurity for 5G and beyond, advancing cybersecurity technologies and end-to-end network visibility to secure the smart cities. So in conclusion, I think telecoms technology will not evolve on its own. It will be a confluence of present and future technologies. Technologies like quantum computing, agentic AI, AGI, even people talk about ASI, physical AI, embedded, embodied AI. And then, of course, there will be different standards that come about. So with this, it will come with opportunities, but at the same time, we have to do it with care because there will be associated risk involved. So the real challenge ahead is to strike a balance to harness the opportunities while staying ahead of the risk. To sum up, let me leave you two key messages. The first is about opportunities, a hyper-connected future with faster speed, multiple devices, and intelligent services that will transform industry and societies. The second is about risk, AI vulnerabilities, inconsistent security policies across nodes and networks, privacy leakage, and the urgent need for resilience. Not just prevent attacks, but to recover quickly when breaches do happen. Securing the future of communications means embracing both sides of the equation. It requires innovation, vigilance, and collaboration across nations, industries, and research communities. So that's the journey ahead, and it is one that we all must work together. Thank you.
Thank you for your presentation, Mr. Marcus Tan. Any comments or questions for the floor, please?
Thank you for your presentation. 5G and 6G network mostly based on IP infrastructure. That means besides traditional IP attacks, do you have another and specific network specific attacks like wireless network like 3G or 4G? Can you use other attacks for your attacks module?
Right.
Like traditional IP attacks,
right.
IP network attacks. Yeah.
Okay, thanks for the question. It's a good question. So in the TSIC, we are looking at not just only IP attacks. That's on the right side, whereby the core connects to the internet. But I think on the right, the left-hand side, will be attacks from the RAN, for example. In TSIC, we are basically looking at the moment, the three particular attacks, the core network flooding attack, DGA. Okay, I agree that those are a bit related to IP, but then the other one is we're looking at SIM cloning attack, for example. And the other one will be the roaming from 5G to 4G and vice versa. Because you have to ensure that the security policies, it has to be end-to-end. Otherwise, when you roam from 5G, for example, to 4G, your security policies that is intact in 5G, it becomes exposed, and then the user will be exposed to, vulnerabilities and attacks. So yes, so these are the attacks that are quite specific to telco, not exactly IP. And hence, in our team, we have people who are, we have team members from both sides, people who are IP network specialists, as well as the telco specialists, the one who understand the, the traditional SS7, telco kind of traffic.
What are the two attacks you have implemented in your system until now?
Sorry,
you talk about two implemented attacks in the system.
Yeah. Yes, the two implemented attacks was the network flooding attack, basically the DDoS attack, flooding the core network itself. Second one is the DGA attack, whereby nowadays, malware use DGA algorithm. They will hide at the network, and then they will keep, instead of sending to a fixed IP address CNC C2 server, we use certain algorithm to access a certain URL, which consists of string of a randomly generated string. Yeah, so we have also implemented the ways to detect such attack from the core network itself. SIM cloning attack, we are almost there. I think we have a first version already. And remember the T-SIG project, we are working with ST Engineering, which is the biggest, at least in Singapore, the biggest defense and technology system integrator. So they are our partner. They will incorporate the outcome, the R&D outcomes of this T-SIG into their service offering to their existing clients. So they have a wide network of clients, both locally as well as internationally. So I think the T-SIG key point is that we will be from R&D all the way to translation and commercialization. Thank you.
Thank you for the presentation. Yeah, thanks, Sir. Okay, let me invite the next presenter, Ms. Enyemo, to present the HackerWeb Cybersecurity and Privacy Awareness and Personalized Multilingual Chatbot.
Good afternoon, honorable chairmen and participants. I'm Dr. Enyemo from Natural Language Processing Lab, University of Computer Studies, Yangon, Myanmar. It is my great pleasure today to be here to present our proposed work, HackerWeb Cybersecurity, Privacy Awareness, and Personalized Multilingual Chatbot. Cybersecurity and privacy risks threaten to undermine the benefit of ICT-driven development. Cyber attacks occur globally every 39 seconds, and 95% of breaches involve human error, and it often through phishing or mishandling malicious files. This incident disrupts essential services because it causes financial loss and erodes trust building in digital infrastructure. Moreover, it limits the potential of ICT to contribute to the sustainable development goals. Traditional security tools remain overly technical, costly, and inaccessible to many users. The digital transformation of ASEAN is challenged by rising cybersecurity and privacy risks, with human error driving most attacks. Moreover, existing tools are often too technical and medium-sized enterprises are vulnerable. It also lacks in personalization and language support for ASEAN users, and it delivers one-size-fits-all solution that fails to meet local needs. Therefore, in this work, HackerWeb introduced and empower multilingual cybersecurity assistant that combine real-time threat detection, privacy risk awareness, and personalized conversational guidance. Pilots in ASEAN University and SMEs will evaluate improvement in awareness and safer practice with plan for regional expansion through localized datasets, browser extension, and gamified learning. By making cybersecurity accessible and inclusive, Hackaway will strengthen digital resilience and supports progress towards the sustainable development goals across ASEAN. Therefore, in this way, as the proposed method, Hackaway is developed as a hybrid ICT solution, integrating AI personalization with cybersecurity scanning tools. The core functions include conversational AI chatbot for personalized guidance, threat scanning tools such as URL find with categorization or risks, privacy risk detection for hidden permission trackers and web practice, user-friendly interface with interactive result history and progress tracking, browser extensions such as real-time scanning during browsing, and gamified learning such as quizzes, badges, and challenges to engage users. Community health platform for shared experiences, threat reporting, and PR learning. In integration with security API, it links to the ASEAN and global threat intel databases. For regional deployments, it collaborates with university, SMEs, and NGO for ASEAN-wide adoption. This is the model architecture for GeneraChat. It is based on the retrieval augmented generation architecture. As the domain knowledge cybersecurity database, the security bugs are collected and is converted into the chunks. And then it is embedded using the multilingual embedding model, and then they are stored in the Vector database. When the user asks a query, the query is preprocessed, such as sanitizing inputs, and it is checked for the ingestion detected. If ingestion is detected, reject the query and generate with the predefined response. If it is not detected, the query is converted into the vector using the multilingual embedding model. The relevant chunks are retrieved from the vector database, and user information are saved in the user database. The retrieved chunks and user information are combined and sent it to the multilingual large language model, LLM, and then the final result or response is sent back to the user. The generated response is saved to the memory via the ranges to personalize the future response. This is the overall architecture for GeneraChat. As the scientific and technological impact, it enhances the AI training model because the method supports the development of smarter AI models that can detect, interpret, and respond to cyber threats in various languages. In cyber threat detection, by interacting with the user in their native language, the chatbot can more effectively raise awareness about phishing, malware, and social engineering attacks. In scalability and adaptability, the chatbot can be integrated across various platforms, such as a web mobile messaging application, and make it a flexible tool for cyber hygiene education globally. As the societal impact, it increases the cybersecurity awareness because it educates the individual in their native language, bridging the digital literacy gap and having users make safer online choices. In privacy empowerment, users become more aware of how to protect the personal data, leading to better individual and societal resilience against identity theft and fraud. Multilingual supports ensure non-English speakers and marginalized communities have equal access to vital cybersecurity knowledge. In digital trust building, it encourages trust in digital systems by promoting responsible online behavior and risk awareness. As the collaborated impact, The chatbot can be a shared, open source or community enhanced tool, and it encourages contribution from international researchers, linguistics, and cybersecurity experts. Moreover, it can be adopted by governments, educational institutions, NGOs, and private sectors to promote cybersecurity training and awareness. As the scientific output, it demonstrates the cross-domain application by combining NLP, cybersecurity, and user engagement technology. Moreover, the output can be the benchmark datasets because the creation of annotated multilingual datasets related to cybersecurity awareness helpful for training and evaluating other AI systems. As the associated output, a freely accessible chatbot that can be used by the public for cybersecurity and privacy education. Moreover, the output can be the language-specific cybersecurity books or threat-related terminology databases that can be shared with the public or research community. As the collaborated output, the collaborating opportunities with the university, cybersecurity organization, language technology researcher, and international NGOs. Moreover, the formational team with the expertise in linguistics, cybersecurity, law, and education can be awarded. Let me conclude my presentation. Therefore, in this work, HackerWeb contributes to improve cyber literacy through adaptive learning to strengthen secure ICT ecosystem, and it builds trust resilience in digital system. Moreover, it provides multilingual, personalized, and locally relevant tools, and it supports ASEAN regions for a secure and smart community, and it reduces harm from cyber attacks, and it enables safer, more inclusive digital participation. Thank you for your listening.
Thank you for your presentation. Any comments and questions for the floor, please?
Hello, yes, thank you for your presentation. I would like to ask, because your project is about trying to build a chatbot, right?
Yes.
And what will be the difference that you may provide with regard to those already available generative AI that could serve as the chatbot? Like we have many, like ChatGPT, Gemini, DeepSeek, yeah. So
Yes.
yeah, please try to comment on this. Thank you.
We mainly focus for the cybersecurity awareness, especially for ASEAN user, local ASEAN user. Yes, therefore, we would like to develop the chatbot for cybersecurity awareness for ASEAN members.
So yeah, what I meant is that we can use those tools to all the Asian countries, right? So how could this be a difference? That what you are going to build would be like how many years? 2 years on the road. Yeah,
Yes.
until then, yeah, what would be the thing that could be more difference?
Yes.
That would be specifically only for those in our Asian region. Yeah.
Yes, ChatGPT, Gemini AI, such as they cannot detect the real-time threat detection. Moreover, knowledge may be limited for local ASEAN user for cyber security policy, and rules. Policies and rules. Therefore, we develop especially for using the ASEAN security, ASEAN countries' security, privacy policy, and rules. Yes.
Any questions and comments?
Thank you for your presentation. Maybe a short question.
Yes.
what is your input to your system? What is query do you mean?
Yes, input maybe can be various ASEAN languages. Yes. Yes,
That mean-
we would like to develop for ASEAN countries. Yes, input can be the ASEAN languages.
That means the text user
Yes,
Keep-
input
yeah.
can be text or image or
image. Yeah.
Yes.
Thank you.
If there is no answer or questions, thank you for your presentation. Yes.